Okay, chapter 6, discrete probability distributions. We're going to have 3 learning objectives. Identify the characteristics of a probability distribution. Distinguish between discrete and continuous random variables. Compute the mean, variance, and standard deviation of a probability distribution. Let's get started. What is a probability distribution?
It's a listing of all outcomes of an experiment and the probability associated with each outcome.
The probability of a particular outcome is between what? What 2 values must it be between?
0 and 1.
0 indicating
It's not likely going to happen. Not going to happen.
not likely going to happen. 1 being
It will happen.
Likely.
you'd be willing to bet on it.
Mhm.
The outcomes are mutually exclusive events. What's it mean when we say we have 2 mutually exclusive events?
That means one can happen and the other one can't.
If one happens, the other cannot. And you can't have one can't take on 2 outcomes.
Right.
It's either outcome A or outcome B. The list is exhaustive. That means the sum of all probabilities is going to equal 1 or 100%. All right, here we are for an example. Let's toss a coin. We flip a coin 3 times. Each time, what is going to be our expected face when it lands? What's it going to be faced on?
Yes or chance.
All right, so the 3 particular outcomes are, it can have 0 heads, 1 head, or 2. So think about it. You flip it 3 times. It can either take on 0, 1, 2, or 3 heads. Now, what's the probability distribution for the number of heads? Okay, so let's look at it. Let's go ahead and get the let's get this over here. You see the
Oh, spray lamp.
Laying down right there, spray.
Oh, on the board, yeah.
okay, so we say that there's 3 potential outcomes. Thank you. So the number of heads. And we are going to define that as X. So how many times? It can either be 0,
1 or 2.
1, 2,
3.
or 3.
Mm-hmm.
Now, what's the probability of this outcome?
So if we're flipping it 3 times, the probability could be 3 or 1.
Flip it 3 times.
Could be 3.
It could be what? If I flip it 3 times, what's the probability of it being 0 heads?
Like 1/3?
Okay, 1, because anything else, it's going to be a tail.
Uh-huh.
At 2.
This in here says 1/8.
Where are we getting 1/8?
It looks like that there's 8 possible results, is what it's saying.
What are the 8 possible results?
So the first one could be all tails. The second one could be 2 tails and 1 head.
All tails,
2 tails and 1 head.
2 tails, 1 head.
1 tail. Wait. No, there's so it would be the first and second roll would be a tails and the third roll would be heads. And then the third possible is a tails, heads, tails. And then the fourth is a tails, heads, heads.
So what are 8 potential? There's 3 potential outcomes for rolling a head.
Right.
But you got to take in, if it's not a head, there's the outcomes of it being
outcomes.
the other, or a tail.
So this is the outliers, like what else it could be, is what it's,
These are any types of combinations of what we could have
right.
with 3 rolls.
So all the possible outcomes.
So all possible outcomes. So let's
Okay.
say these again. We had all tails,
All right. So it was tails, 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 and then tails, tails, heads.
2 tails, 1 head.
And then tails, heads, tails.
Summarize them for me. How many tails?
There was 2 tails and 1 heads again, but it's tails, heads, tails.
All right, so let's.
Because it goes by first, second, and third toss.
So we could have 3 tails. We're going to use T and H.
Yep. And then you could have
2 T's,
and 1 H.
1 H.
And then you could have a tails, a heads, and the tails.
So same, 1 H, 2 T's.
And then you could have a tails, heads, heads. And then heads, tails, tails. Heads, tails, heads. Heads, heads, tails. And then 3 heads.
1, 2, 3, 4, 5, 6, 7, 8. 8 potential outcomes, 3 of which include the heads. But then let's look at all other combinations. So the probability of rolling rolling 0 heads. If we roll 0 heads, that means we just rolled 3 tails. So the probability is what?
1/8.
1/8. What's the probability of rolling 1 head?
Be 3/8 because there's only 3 possible solutions over there.
3/8. Probability of rolling 2?
2/8.
3 H's.
3. Oh, you could do the 3 heads down there too. Okay. And then 3 heads is 1/8.
3 heads right here, 1/8. Now, if we summarize those, one, 4, 7, 8, 8 over 8, 4, 1. Here we know we meet that definition. All probabilities sum equal 1. And each one of these outcomes are mutually exclusive. Okay, random variables. These are a random variable. That is, when we flip that coin, it was by chance what value showed up. Could we influence it?
Well, you could influence it by picking it up and turning it over, but
Yes, but we did not.
Yeah,
If
so
we are just flipping the coin up in the air,
you can't influence it.
no. So by chance,
Mm-hmm.
did it take on one of these values? Discrete random variables. Let's distinguish between discrete and continuous random variables.
A random variable, a discrete random variable is a random variable that can assume only a certain clearly separated value.
Can assume only clearly separated values. It is usually the result of counting. Okay, let's look at the numbers. Rolling a die. How many possible outcomes when I roll? How many possible outcomes can we achieve?
Depends on how many times you roll it.
One roll,
One roll is 6.
6 particular outcomes. What are those outcomes in a range?
1 to 6.
1 to 6. They can only take on those values of 1 to 6. A continuous random variable.
A continuous random variable is a random variable that can be continuous. So like measuring the width of a room, the height of a person, or pressure in an automobile tire.
All right, so a continuous random variable can assume an infinite number of values within a given range. Usually the result of some type of measurement. Remember, discrete takes on the role of when we are counting. How many students are in this class?
2.
Okay, that is an example of discrete. How many cars go through a car wash within an hour? That, if I was measuring that, that would be a discrete random variable. Okay, a continuous. Of the students that are in the class, let's just say of the individuals in the class right now, the weight of each student. We could take on, if I looked at the lightest to the heaviest, everyone else in here, we're going to take on some value in between those.
Mm-hmm.
But it can't be in accounting. We can be anywhere in between those. Okay, if I look at songs on a CD. Okay, if you, again, you can look at the length of all the songs, creating a minimum and a maximum, and every other song is going to take on some value. In your organizations, income. You know, a hot topic in economics right now and in debate on finance, income inequality. You know, look at the highest ranking individual in your organization. Look at your CEO. Compare their salary to someone just hired in. Okay, starting position. Assuming the CEO is the most highly compensated and the person just coming in would be the lowest. Everyone else employed on payroll is going to fall somewhere within that range.
So they're the continuous.
That would be the continuous.
Okay.
It's going to be somewhere within there. All right, so now we're going to look at the mean. Here's where we're going to handle these objectives. So we just defined discrete and continuous random variables. Now we are going to focus on the mean of a discrete probability distribution. When I say mean, what am I referring to?
The expected value.
The expected value. The mean of a probability distribution is also referred to as the expected value. What symbol am I going to use to reference The mean?
Move.
What's the big E?
Sum.
The sum of X, the probability of X. Okay, so what we are looking at is the mean of a discrete probability distribution. All right, let's look at an example. Local auto dealership. All right, sales managers analyzing sales. You see this example in the book?
Pelican Ford.
Pelican Ford. Okay, sales manager, John Ragsdale, sells new cars for Pelican Ford. John usually sells the largest number of cars on Saturday, and he has developed the following probability distribution for the number of cars he expects to sell on any particular Saturday. So in this example, number of cars sold, we're going to call that X. And the probability look at it, the probability of X occurring. So John, it says here we can expect to sell 0 to 4. What's the probability that he would sell 0 cars?
Says 0.1.
0.1?
Mm-hmm.
Okay. What's the probability of selling 1?
0.2.
0.2?
0.3. 0.3. 0.1.
Okay. What's the sum of all these probabilities equal to?
1.
Okay. Remember, I've got a mutually exclusive, collectively exhaustive. They're going to sum up to 1. Okay, so applying this formula here, how am I going to calculate the mean of this discrete probability distribution?
So you're going to multiply X times the probability.
Okay, so we are going to use, in this example here, we're going to apply this formula.
Mm-hmm.
And it says that we're going to sum the probabilities of X occurring. So what's the probability of selling 0?
0.
What's the probability of selling 1?
0.2.
All right, so 1 is 0.2. 2,
0.6.
0.6. No, it's going to be 0.3.
0.3.
And then 0.3 again. And 0.1.
And then 0.1. And what does that sum to?
2.1.
2.1. You see how we're getting this? All right, now the variance and the standard deviation. What's this going to tell us?
It's just gonna tell us the variability of cars that could be sold on Saturdays.
So mean and standard deviation. All right, it's going to measure, remember, standard variance and standard deviations are going to be measurements of dispersion. It's going to be a measurement of distribution around the mean. All right, so how are we going to solve for this? So John, we said the mean, what was the mean equal to?
2.1.
All right, let's get our boundaries back up. So we just defined the mean is equal to 2.1. So on any particular Saturday, John expects to go in and sell 2.1 cars. Does that mean that every Saturday he goes in, he will sell 2.1 cars?
No.
No, so to come up with a number of expected values, expected number of cars he could sell, we need to look at the variance and standard deviation. Now, how are we going to summarize this?
It's X
It's the
minus
sum of what?
X minus mu.
Squared.
With the probability of X. Okay, so remember, the steps that we're going to use, subtract the mean from each value. Remember from last week when we worked this example of calculating variance and standard deviation, what did we do? We subtracted the mean from each value and squared the difference. We are going to now multiply each squared difference by its probability and then sum all of these resulting products to arrive at the variance. And once we get the variance, let's get here and solve. So we can say the number of cars sold. We're defining that as X. We probably want to. All right, so what's the first thing we want to look at? The probability of X.
Okay.
And then we want to subtract the mean. Then the last piece. So again, number of cars sold, we said could it be anywhere from 0 to 1 to 2 to 3 to 4. And what was the probability of 0 cars?
0.1.
0.1.
0.1. Probability of 1?
0.2. 0.3. 0.3. 0.1.
0.1. So now we want to take X, the number of cars sold, subtract it from the mean.
2.1.
So we want to take 0 minus what?
2.1.
and then square that, and I get what?
4.41.
4.41. Now here, what are we doing?
Take 1 minus 2.1, square it.
And I
That's
get,
1.21.
and then here we want to take 2 minus 2.1 squared, and I get
0.01.
0.01.
Mm-hmm.
3 minus 2.1 squared. You
Point
get
81.
0.881, and finally,
Just 81.
8.
It's just,
4, I got you.
okay. And that's 3.61
0.81,
and 3.61.
3.61. And what are these gonna sum? Well, we don't need to sum right yet. Okay, last step. We sum over here. What's the last step?
Number of cars sold minus the mean squared. Then you multiply it.
By what?
By the probability times the number sold.
Okay, the probability by the numbers sold.
Number of cars sold.
So what are we multiplying 4.41 by?
4.41 multiplied
By 0.1.
by 0.1.
So we're gonna take this last value and multiply it by the probability of X. So here,
Mm-hmm.
so 4.41 multiplied by what? 0.1
1.
is equal to
0.441.
0.441. Now here, 1.21 multiplied by its probability is equal to
0.242.
0.242 and 0.01, so
That's
0.003.
probability of selling 3 cars and the distribution around it, 0.81 multiplied by the probability,
That would be 243.
and finally,
0.361.
0.361.
Mm-hmm.
Now we want to sum,
That's 1.290. 1.290.
1.290.
Mm-hmm.
Okay, now, this is our variance. How do we get the standard deviation? Remember, the standard deviation is equal to
The square root.
Square root of the variance.
of the variance. So in this example, we would take the square root of
1.29.
1.290, and that gives me
1.136, I think is what it is.
1.136.
1.136. So here is our summary. We just calculated the mean, the variance, and the standard deviation of a discrete probability distribution. Any questions?